Hello everybody, in grade 10, today we will speak about equilibrium of coplanar forces act at point. First of all, if a body in equilibrium, this means that the resultant of all forces acting on this body is equal to first equilibrium of a body under the action of two forces. If a body is in equilibrium under the action of two forces only, then the two forces are equal in magnitude, they are opposite in direction, their lines of actions are on the same straight line. For example, a body suspended by light string. If this body in equilibrium, there is two forces acting on this body, which is the weight and the tension. These two forces are same magnitude and same straight line and opposite direction. Another example, a body on a smooth plane. This body is in equilibrium. There are two forces acting on this body, which is the weight and the reaction of the plane. These two forces are same magnitude, same straight line, and opposite direction. Second, equilibrium of a body under the action of three forces. If we have three forces, F1, F2, and F3 are in equilibrium, this means that the resultant of F1 and F2 is equal to F3 in magnitude and opposite direction. Also, the resultant of F1 and F3 is equal in magnitude to F2 and opposite direction, and so on. Let's try to solve this problem. F1, F2, and F3 are three coplanar forces meeting at a point. Their magnitude are 12, 12 root 3, and 24 Newton respectively. If these forces are balanced, find the measure of the angles among the three lines of action of the three forces. Let's try to solve. F1, F2, F3, three forces. Suppose that the angle between them, theta 1, theta 2, and theta 3, we want to find theta 1 and theta 2 and theta 3. First, the resultant of F1 and F2 is equal to F3, which is 24. We can apply the rule of the resultant of two forces that we studied in last lesson. R square equal F1 square plus F2 square plus 2F1 F2 cosine theta 1. We know that R is 24, F1 is 12, F2 is 12 root 3, and apply this rule, and we can find theta 1 is equal 90. Similarly, the resultant of force 2 and force 3 equal F1, which is 12. We apply the same rule, R square equal F2 square plus F3 square plus 2F2 F3 cosine theta 2. From this rule, we can find cosine theta 2 equal negative root 3 over 2, which means that theta 2 is opposite angle. We can find theta 2 equal 180 minus 30, which equal 150. We can find the last angle by 360 minus 90 plus 150, which equal 120. Another two rules for equilibrium to three forces. If we have F1, F2, and F3, three forces, if these three forces are in equilibrium, and we can transfer these three forces to make a triangle. F1 is parallel to AB, F2 is parallel to BC, and F3 is parallel to CE, CA. We can see that this triangle is triangle of forces, which is mean the F1 over length of side AB, F1 over AB, equal F2 over BC equal F3 over CE, and this is the triangle forces rule, which if three forces said if three forces acting at a point are in equilibrium and triangle is drawn whose sides are parallel to the lines of action of the forces and taken in the same cyclic order, then the lengths of the sides of the triangle are proportional to the magnitudes of the corresponding forces. For three forces also, if we have three forces, F1, F2, F3, and the angle between them are theta 1, theta 2, and theta 3, from the triangle force we can apply the sine law, and we will investigate F1 over sine theta 1 equal F2 over sine theta 2 equal F3 over sine theta 3, which this is Lami's rule. If three forces meeting at a point and acting up on a particle are in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the two other forces. Let's try to solve problem number one. Three coplanar forces of magnitude F1, F2, and 18 Newton meeting at a particle in balance. If the measure of the angle between the line of action of first and second forces is 90, and between the two, the second and the third is 120, find the value of each of F1 and F2. We have that this forces 18, F1, F2, and the angle between them is 90, 150, and 120. We apply Lami's rule, which is F1 over sine 120 equal F2 over sine 150 equal 18 over sine 90. From this, we find F1 equal 9 root 3 n, F2 equal 9 n Newton, 9 root 3 Newton, F2 9 Newton. Try another problem. A weight of 200 gram weight is suspended by two string of length 90 centimeter and 120 centimeter fixed in two horizontal points. The distance between them is 150 centimeter. Find the value of tension in each of the two strings. First, we will using Lami's rule. In this figure, the tension is T1 and the tension 2 is T2 and the weight is 200. Suppose that the angle between the tension and the vertical is theta 2 and theta 1. From this figure, we can find CD. First, the triangle ABC is right angle because 150 squared equal 90 squared plus 120 squared, which means that the angle C is 90. We can find CD by Euclidean equal 90 times 120 over 150, which equals 72. Also, we can find AD and BAD will which is equal 96 and BD equal 54. From this we can find sine theta 1 which equal 54 over 90 and sine theta 2 equal 96 over 120. We can apply Lami's rule. T1 over sine 180 minus theta 1 equal T2 over sine 180 minus theta 2 equal to 100 sine 90. T1 over sine theta 1 equal T2 over sine theta 2 equal to 100. From this, we can find T1, which is equal 120 gram weight, and T2, which is equal 160 gram weight. You can apply triangle force from this shape. The triangle force is CDF. DC is the acting on the force of 200, and CF is the angle, is the side which is acting on the force of T1, and the FD is the side which acting the force T2. We can find the lenses CD and DF and CF, and we can apply the triangle forces to find the T1 and T2. We can try this. Thank you. You can try solve these problems, and thank you.